Hello students, welcome. Previously, lesson 26, form 3, topic 2, we were dealing with the fourth aim of direct titration, which was determining the molar mass of the analyte. So today, lesson 27, we are going to do the fifth aim of direct titration, which is determining the percentage composition of the analyte. So I want to start with question number 1, and we are told in an experiment, 12.6 grams of a mixture of anhydrous sodium carbonate and sodium chloride was dissolved in water and made up to 250 centimeter cube of solution. So full stop, we are told 25 centimeter cube of this solution required 20 centimeter cube of 1 molar dilute hydrochloric acid for complete neutralization. So we are asked to calculate the percentage of sodium carbonate in the mixture. So in this question, we have asked the percentage composition of or the percentage of sodium carbonate in the mixture. But tomorrow even you can be asked the percentage of sodium chloride in the mixture. So we start by first of all knowing the standard solution. Here we are having hydrochloric acid as our standard solution. So we are going to start by looking at its number of moles. So we are going to start with the moles of hydrochloric acid. So what have we said about the formula for calculating moles? Moles is given by molarity times volume used over 1000. That's the formula. So what do we have as our molarity of hydrochloric acid? We are given 1 molar. So we're going to say 1 times, then the volume is 20. So divided by 1000, which is in the formula. So here we are going to get 0.02 moles of hydrochloric acid. So next, students, you have to know the mixture is sodium carbonate and also sodium chloride. But only one of them will react with hydrochloric acid, and that is the sodium carbonate. Sodium carbonate will react with hydrochloric acid, but sodium chloride does not react with hydrochloric acid. So next we have to write the reaction between sodium carbonate and also dilute hydrochloric acid. So we have sodium carbonate solution reacting with the hydrochloric acid, HCl, aqueous. We will get sodium chloride, aqueous, plus water, liquid, plus carbon dioxide, which is a gas. So we are supposed to balance the question. We are going to have 2 in the side of hydrochloric acid and 2 in the side of sodium chloride. So that reaction is balanced like that. Next, let us see the mole ratio between sodium carbonate ratio hydrochloric acid. So it is 1:2. There's 1 hidden there and we have 2 here. So we know the number of moles of hydrochloric acid. We have gotten 0.02 here. So if we have 0.02 moles as the number of moles of hydrochloric acid, we can get the one for sodium carbonate by using the mole ratio. So we're going to say 1 times 0.02 divided by 2. So here we are going to get 0.01 moles of sodium carbonate solution. That will be the number of moles of sodium carbonate solution. So remember, you are told 25 centimeter cube of this solution required 20 centimeter cube of 1 molar dilute hydrochloric acid. So that means this number of moles of sodium carbonate solution contains volume of 25 centimeter cube. So we can ask ourselves, what about 250 centimeter cube of solution? Because initially the mixture was dissolved in water and made up to 250 centimeter cube of solution. So we are going to say and relate. We are going to say if 25 centimeter cube of sodium carbonate solution has number of moles of 0.01, which we have gotten by the use of the mole ratio. We ask ourselves, what about 250 centimeter cube of solution of that sodium carbonate solution? We are going to cross multiply. We are going to say 250 multiplied by 0.01 divided by 25. So here we are going to get 0.1 moles. Okay, next we have to know the RFM of sodium carbonate solution, because that one will help us to get the mass of sodium carbonate in the mixture. So we are going to say RFM of sodium carbonate will be, so the RM of sodium is 23 times 2, because we have 2 sodium there, plus 12 for carbon, plus 16 times 3 for oxygen. We are going to get 106 as our RFM. So next we are going to get mass. What's the formula for calculating mass? Mass is given by moles times RFM. So the moles of sodium carbonate is 0.1 times 106. Here, what we are going to get will be 10.6 grams. Okay, to go back to the question, we are told calculate the percentage of sodium carbonate in the mixture. So if we want to get the percentage of sodium carbonate, we have to know the mass of sodium carbonate, which we have gotten 10.6. Then we can divide by the mass of the mixture, which is 12.6. Then we multiply by 100. It will give us now the percentage of sodium carbonate in the mixture. So if I want to get percentage of sodium carbonate, the formula will be, I have to have mass of sodium carbonate divided by the mass of the mixture, then you multiply by 100%. So this will be equal to, what is the mass of sodium carbonate? You have gotten 10.6 divided by the mass of the mixture. They have given us 12.6 grams. It is here, 12.6 grams. So divided by 12.6 grams, then we multiply by 100. So here we are going to get our answer as 84.13%. So that will be the percentage of sodium carbonate in the mixture. In case you are asked the percentage of sodium chloride in the mixture, you only take this, then you subtract from 100. So you say 100 minus 84.13%. What you get from there will be the percentage of sodium chloride in the mixture. That will be the end of our lesson.